Hi, this is Bill from Sparky Channel, and today I'll be bringing you round 2 professional division of the Ideal National Championship 2021 from Nashville, Tennessee. Here are the competition rules. Greg is to determine the receptacles with problem wiring causing 3 arc fault breakers to trip in the panel. And then he's to find a 3-digit code by testing through the breakers in sequential order, that is breaker 1, breaker 2, etc. And then he's going to need to write down the receptacle number in the order that the faults are found to get the code to open the lockbox. And then in the lockbox, he'll get a tool he needs to work on task 2. Greg has grabbed his Ideal fork meter and set it to continuity. I'm going to stop the video for just a second here to explain how Greg is doing this testing. You see, he's got his meter set to continuity. He's got one of his leads on the hot terminal of the arc fault breaker and one of the leads on the neutral terminal of the arc fault breaker. What he's looking for is a short circuit. He's looking for a fault in that circuit. And if he hears a beep, then he has continuity. You're not supposed to have continuity between the hot and the neutral. So if he hears a beep, he knows there's a fault in that circuit breaker. The breakers on the left are odd numbered breakers, so it'd be 1, 3, and 5. The breakers on the right are even numbered breakers, so that's 2, 4, and 6. His continuity test got beeps on circuit breaker 1, 3, and 5 only. So there are faults in circuit breaker 1, 3, and 5. Now Greg is breaking out the Ideal Sure Traced circuit tracer kit. And it comes with a number of different cables and leads, and he's going to set it up the way he wants it for his test. Since Greg knows the arc fault breaker number 1 has a fault, he's going to take the hot and neutral wires off of that breaker and hook the leads to the Sure Test tracer. I need to take another short break to explain what Greg is doing right now. You see, the device on your left is the transmitter. That's hooked up to the hot and neutral wires that went to the first arc fault circuit breaker that we know was showing a fault. The device on your right is the receiver. That's the one he has in his hand right now. And Greg is smart. He puts it at the lowest setting. He's working in the 30s. The receptacle that has the fault will have a higher reading than the other receptacles. And here we see that Greg has written down number 1. So receptacle 1 was the problem receptacle. Greg is now taking the hot and neutral wires off of arc fault breaker number 2, and he's hooking up his Sure Trace to those wires. Now Greg has grabbed his receiver, and he's going to test out the various receptacles to find out which one is causing the problem. Oh, he's spending a lot of time there with number 3. receptacle number 3. Look at that. He's looking at it. I bet it's number 3. He's checking the other ones, make sure there's no higher readings than the one he got on number 3. But he looks at number 3 again. And yep, I bet it's number 3. Yep, it's 3. Now Greg is going to take the wires off of arc fault breaker number 3 and hook the SureTrace transmitter to them. Receptacle number 5 is getting a lot of attention. I think it's number 5. Okay, he's going right to the lockbox, putting in the code. It should be 135. And there it is. He's got it open. He's got a tool out of there. It's the ideal torque screwdriver, which he'll need for part 2 of this competition. So here's Greg on the other side of the competition board for part 2, panel installation. So he is to mount and install an unassembled Siemens panel. The panel cabinet must be centered on the wall and 6 foot AFF to top of cabinet. AFF means above finished floor. Then he'll have to install the panel board and the main breaker. Notice that Greg already has a 6-inch magnetic level on the Siemens unassembled panel. Now he'll screw in one screw at the top of what we call a tub, and watch, he's going to look right at the magnetic level. He didn't have to reach for one or anything. It was already on the tub. So now he's putting in more screws. See how much quicker that is to put your magnetic level on the side of the tub first? And notice the way he handles the unassembled panel. There's no nicks or dings or dents or anything. You know, it's a professional job. It's the kind of job that you would want on your house. Greg is removing the dead front from the guts of the panel. Now Greg is installing the guts of the panel. Now he's securing the guts of the panel to the tub. And now he's installing a 20 amp circuit breaker. Greg is now working on a 2-gang exterior box, which will receive a GFCI receptacle and a standard receptacle. Greg's now going to put on the little mounting ears that you put on diagonal corners of the box for installation. A 1/2 inch EMT fitting is added. Greg is to put the box 16 inches AFF on center. That means above floor finish, and the 16 inches should come right to the middle of the box. Now Greg is going to be drilling a hole in the bottom of his panel for a 1/2 inch EMT fitting, and he's going to use this blue ring that is made by Ideal, and it has little magnets on the inside of it to catch metal filings as you're drilling through the metal. Now Greg is going to make a box offset on his 1/2 inch EMT.
ground bar for our panel. I don't think we have a ground bar for our panel. Greg, don't mount the main breaker. Yeah, I found that out. And no ground bar. Don't worry about it. Just want it to, like, still no one has finished yet.
And now Greg is going to start wiring the box. And right now he's adding a green wire, which is called an equipment grounding conductor. It bonds the box to the grounding system, and so he's tightening that up very well. And now Greg's going to grab the ground wire, cut it to length, strip it, put it in with his EGC, that's equipment grounding conductor. Now he's going to add a green wire, both ends of a green wire, and then watch this. He'll cut them off and strip them to length. It's just a little nice trick to do it a little faster. He's put loops on the wires, and now he's cut the hot wire and the white neutral. And now Greg is making pigtails, both black hot and white neutral pigtails, and he's stripping them and getting them ready. And he'll be working on the standard receptacle first. Now he's screwing down the pigtails to the receptacle. He's putting on the white pigtail right now. Now he's going to take one of his ground pigtails and put it to the green grounding terminal of the receptacle. And now he's going to strip the black and white wires. And now he'll add the other green pigtail to the green grounding terminal of the GFCI receptacle and tighten that down. And now the white line wire goes to the line portion of the GFCI on the neutral side. Now here's the black line wire, which goes to the hot side of the line portion of the GFCI, and they're tightened down. Now he's going to work on the load portion of the GFCI, adding the black hot wire to the load portion on the hot side of the GFCI. And now he's going to take the neutral wire and add it to the load portion of the GFCI on the neutral side. You see, the standard receptacle is the load of the GFCI. In that way, the GFCI will protect the receptacle from ground faults. Greg is now putting on the ideal armor bands. Now Greg is going to install the weatherproof exterior outlet cover, and this is for a 2-gang box. And there's little inserts. See, the standard receptacle is a standard type receptacle, and the GFCI is the Decora style. So he's got to get this the right way around, and he put in his little inserts. Okay, get it to fit just right on there. And there's some little screws you gotta put into place. There's only 13 minutes left in the contest right now. And these competitors are getting pretty tired by now. They've done a lot in a short amount of time. It looks to me like that screw right there just stripped. The one in the lower left-hand corner. Greg is going to make a little note in the box that that screw stripped, so that when the judges see that it's a little loose, they'll know what happened.
No ground bar. Do we know what we're doing? What's that? Okay.
And Greg is going to land the hot black wire on the breaker, and now he's landing the white neutral wire on the bus bar. And now he'll land his ground wire on the bus bar, and he's just loosely screwing these in place because he's going to torque them in just a little bit. Okay, now Greg is looking at the breaker. On the breaker, it states that it is supposed to be torqued to 25 pound-inches. And that's where you find what your breaker should be torqued to. So there he just torqued it to 25 pound-inches. Now he's torquing the bus bar terminals to 20 pound-inches. And where you find that is there's a paper that comes with the guts that will tell you all the torquing specifications for the panel. Now Greg will use the Ideal Wire Marker booklet to mark his wires. Now comes the installation of the dead front. You can see now why he had to take the dead front off of the guts earlier in the project. And Greg is done. He hits his time clock and he's finished. Good job, Greg.
Yeah, thank you, Bill. Thank you.
Now let's see who the 10 pros are who will move on to the semifinals.
Nathan Agnew. Nick Devaney. Charlie